In this video, we're going to discuss more problems about quadratic equation. And for this, let's focus on problems related to speed. Okay. So we know that speed is just distance over time. Okay. So when we say speed is um, 12 miles per hour, it means that in every 1 hour, something takes a distance of 12 miles. So that's simply that is, okay? In every hour, that object, whatever object is that, takes 12 miles within that time range, 1 hour, okay? So we can rewrite this further as s times t, that becomes distance. If we're going to multiply the speed and time, you get the distance. And if you're going to get the time, time is just distance divided by speed. Okay, so that's it for quick review for the formula. So our first problem says that a bus covers a distance of 90 kilometer at a uniform speed. So basically, we do not know this speed. What is that? Okay, what's that speed there? So what's the speed of the bus when it covers a distance of 90 kilometers? We don't know that. Well, we'll continue reading. Is that had the speed been 15 kilometer more, kilometer per hour more? So this is speed. Okay, more. It would take 30 minutes less for the journey. Okay, for the journey. So find the original speed. So what is this original speed it's talking about is actually this one. Okay, so if the speed of that bus is 15 kilometer per hour more than that original speed, than this, okay, the entire journey would take 30 minutes less. Okay, 30 minutes less. So what we're going to do here is we are going to form an equation since the the journey takes 30 minutes less. It's like when you subtract the um, distance over speed in the original and the distance over speed if the speed is 15 kilometer per hour more, that will take 30 minutes less. Okay, so meaning if we have there are two scenarios here that will give us time. Okay, so here we have this one. So let us first let x be the original speed. Okay, okay, so because we do not know that, and that's what it's for that. So it's like saying that a bus covers a distance of 90 kilometer at at x speed. So it's like saying that. So at x speed. Okay. If that x speed, okay, is 15 kilometer or hour more than that x, the journey will take 30 minutes less. So we have two here. Um, let us say t sub 1. So let let us note that the t sub 1 here is the time in which the the bus covers 90 kilometer, the original time. Okay, the original time with the original speed. Okay, so we know that here Okay, we know that this loop, we're going to derive that, we'll have t is equal to d over s. Okay, d over s. Rewrite, not derive, but rewrite d over s. So, meaning, using this 90 and x, we can say that the distance, the original time is just 90 divided by x. It's distance divided by the speed, okay, because x is our speed. Okay, so but uh if the speed is 15 kilometer per hour more, if you're going to increase the speed, it's like that. The idea is, if you're going to increase the speed, the original speed is x, if you're going to increase that to by 15 kilometer per hour, okay, so meaning that's our um second equation for time. Okay, second equation for time is that, um if that, of course, we are covering the same distance, 90. Okay, if the speed is more than that, so what's that more than the original? What is the original? X. And 15 more than that, therefore that is x plus 50. Okay, so t sub 1, which is the time one, it should be greater than t sub 2. Why? Because you have you have 90 divided by something, okay, which is x, and here you have 90 divided by 50 plus that something. Of course, 90 divided by 50 plus that something, this will become a lesser number. Okay, so this one tells us that if, okay, if 15, this is 15, sorry, okay, if that happens, okay, if that happens, if the speed is 15 kilometer per hour more than the original speed, what will happen is that uh, the time taken will be 30 minutes less. Okay, 30 minutes lesser than the original speed. So we have here, it's like saying t sub 1 minus t sub 2 is 30 minutes. Okay, 30 minutes. Okay, so let's continue. Let's continue, what they call this, substituting. Our t sub 1 is 90 over x minus our t sub 2 is 90 x plus 15 equals, since our speed is expressed in hours, a kilometer per hour, this minutes here should also be converted into hours. Okay, into hour. Okay, so you know that 30 minutes is 1/2 hour, so we can say this is just 1/2. Okay, so why is that? Because x is expressed in, our speed is expressed in kilometer per hour, so we should convert these minutes into hour. Okay, so from here we'll do our previous knowledge about uh, fractional equations. So basically the LCD here, the LCD, I'll just get it like that. LCD is just 2x times x plus 15. Okay, so if you're going to multiply this by 2x times x plus 15, this one, so that will become 2x will be divided, so 2x 15 times 90, okay, minus, if you're going to multiply the second one with this LCD, we'll get 2x times 90, so that's 2x times 90. And if we're going to multiply this 1/2 by this, we'll get x plus 15. Okay, so if we're going to continue, we'll have 2 and 90 gives us 180x plus 180 x. 180 times 15 is 2,700. 2,700 minus, this becomes 180x equals x squared plus 15x. Okay? So obviously this becomes 0. So in turn, um, we'll have x squared plus 15x minus 2,700. Okay? So if we're going to factor that, okay, we're going to factor this one. I don't know if it's factorable. This becomes x plus 60, x plus 45. Oh no, x minus 45. X minus 45. Therefore, x equals negative 60 or positive 45. Okay, so we are taking 45 as our value for x. Okay, we are taking the speed as positive. Therefore, okay, the original speed. Okay, therefore you have always to state your answer. Therefore, the original speed of the bus is 45 kilometer per hour, the original speed. Okay, so meaning if the original speed plus 15, that is 60 kilometer. Okay, it's like saying that if the a bus covers a distance of 90 kilometers at 45 kilometer per hour. If that speed becomes 60, because 45 plus 15 is 60 kilometer per hour, the time will take 30 minutes lesser. Okay? So you decide, the idea here is, the general strategy is you decide which part of the speed, okay, is it this which part of this equation, s equals d over t, becomes the subject of your equation, becomes your equation itself. Is it, will your equation be about time, like this one? Will your equation be about speed, meaning we'll express this in terms of speed, but this time is you're expressing our equation in terms of time, so t sub 1 minus t sub 2? Or are you going to express your equation in terms of distance? So you decide in which tree, and understanding the problem will help you decide which of these three elements that will comprise your equation. Okay, here we are expressing our equation in terms of time, of course with the help of the speed, and the time is expressed in terms of the speed and the distance. Okay, so let's proceed with our second problem. Okay, so our second problem is just like, so these are all speed related problems. Okay, so here Ryan covers a distance of 1 kilometer from A to B. Okay, so 1 kilometer from A to B. So let us say that is A there, then we have B here. This is just 1 km. Okay, while returning, his speed is 3 kilometers per hour more than the first half of the journey. Okay, oh, okay, while returning, meaning Ryan goes that way. Then let's make it a different color. So this is the first half of the journey. Then returning. Okay. So that's Ryan going there. Okay. To B, then Ryan going B to A. That's the entire journey. From A to B, then B to A. That's the entire journey. So the half of the journey is A to B. The another half of the journey is B to A. Okay. So it says here, while returning, his speed is 3 kilometers per hour more than first half of the journey. Okay. So the total time taken, look at this, total time taken for the journey is half hour. Okay. Find the speed of the first half, which is this one, and the speed of the second half, which is this one, of the journey. Okay. So now let's represent. Okay. Of course, when Ryan goes from A to B, distance is 1. When Ryan goes from B to A, the distance is still the same, 1. The distance will not change. Okay. So we have here, we don't know the distance from A to B. Okay. It's just that we know, okay, we know that when Ryan returned from B to A, the distance from A to B, and then he returned from B to A, the distance becomes 3 kilometer per hour more. So it's like saying that this is X, uh, kilometer, I'll just gonna change the color. Um, so this is X kilometer per hour, the original speed from A to B. Then when he returned, that's 3 more. So this becomes X plus 3, okay, kilometer per hour. Okay. So since this gives us an idea that, oh, we can express our equation in terms of time, then express that time in terms of distance and speed. Okay. So let's say that this is our time from A to B. Okay. Time from A to B, and that is, what is time again? Time is distance divided by speed. Okay. So since time and the distance from A to B is 1, and the time is X, and the time from B to A, okay, the same distance, but the speed is 3 kilometer per hour more. So that's X plus 3. The total time, meaning if we're going to add this, all of this time, it takes half hour. Okay, it takes half hour. So we can say, okay, we can say that again, this T sub A to B is greater than T sub B to A. That should be greater because 1 is only divided by X if X is positive. Here, of course, X must be positive. 1 is divided by X plus 3. This becomes a bigger number. Therefore, T sub A to B is greater than T sub B to A. So it's like saying T sub A to B plus, because it says total time, T sub B to A, that is just 0.5 hour or 1 half. Okay. Then we are ready to substitute. Okay. 1 over X plus 1 over X plus 3 equals 1 half. So pretty much the same with our original equation. Or problem 1, we have LCD as 2x times x plus 3. Okay. If we are going to multiply this with the LCD, we have this one. Multiply with the LCD, we have 2x, 2 times x plus 3. If we're going to multiply with the LCD, this one, x plus 3 will be cancelled. will become 1, so therefore you have 2x. Then if you're going to multiply this with the LCD, we'll have x times x plus 3. So here we have 2x plus 6. Then we have 2x. Then we have x squared plus 3x. Okay, so I think we'll have, this becomes 4x. Okay, so this becomes 0. So x squared plus 3x minus 4x and minus 6. Okay, and minus 6. So you'll have x squared minus x minus 6, factoring this one, you'll have x minus 3 and x plus 2. Am I correct? Yeah, that's x minus 3 and x plus 2. Therefore, x equals 3 or negative 2, and we are going to take the positive 3. Okay? So what does it tell us? Is that if this is A and this is B and this is what this one is 1 kilometer from A to B, that's the first half of the journey, which is x, that is 3 kilometer per hour, just this one, okay, which is x. From B to A, I'm just gonna write it that way. From B to A, okay, it's 3 hours more, so that means this one becomes 6 kilometer per hour, double. Okay, the speed just double. So again, the first half of, so we have to rewrite it. The first half of the journey is 3 kilometer per hour. The speed on the first half of the journey, the speed on the second half of the journey is 6 kilometer per hour. So yeah, that's it. So let's proceed to our next problem. Okay. So our next problem is all about, let's try to read. A motorboat makes a round trip on a river of 45 miles upstream in 45 miles. So a motorboat makes a round trip on a river of 45 miles upstream and 45 miles downstream, maintaining the constant speed of 12 miles per hour relative to the water. The entire round trip takes 8 hours. 8 hours. Okay. Also, this one tells us that, oh, we can express our equation in terms of time. Okay. So what is the speed of the current? Okay. So the current of the water. Okay. So here's the explanation to this according to physics. Okay. If the suppose the like that, and the current of the water, okay, the current of the water is going that way, okay, I'll say the direction, okay, the direction of the current of the water is going that way, okay, let us make some arrows there, okay, or let's make arrows there, okay. Then when you, this means that when you go along with the current, you're going downstream, okay. So this one, if there is the direction, you're downstream. That's downstream. Okay. When you go against the current of the water, okay, you go against, meaning that's upstream. Okay. So accordingly, when you go downstream, meaning you go along with the current. Okay, of course you have your original speed. Okay, you have your original speed when you have, let us say, motorboat, then you go downstream. The speed of the current, because there is a speed of this current. Okay, current of the water, there is a speed on that, of that. The speed of this current here will be added to your speed. Okay, suppose your speed going downstream is, let us say, 10 miles per hour. Okay, then there is already a speed of the current which is 2 miles per hour. The speed of this current is 2 miles per hour, and you're going along with that current, and your speed is 10 miles. Therefore, your total speed will become 12. Yours is 10, your motorboat speed is 10, let us say like that. Then the speed of the current is 2 miles per hour. Therefore, the total speed will become 12 miles per hour. So, meaning, the speed of the current will be added to your speed. Okay, to your speed. And that's opposite when you go upstream. Okay, and say opposite. If the speed of the current is 2, okay, 2 miles per hour, then your speed, because you're going against the current, you're going up, or you're going against the current. Okay, let us say your speed is 10 and the speed of the current is 2. The speed will become 8. So your speed will be subtracted by the speed of the current because you're going against the current. Okay, so that's the idea there. Okay, so the question here is, what is the speed of the current? So we do not know the speed of this current, so that's what we're going to represent a variable. Okay, represent a variable. So the speed of the current here is x, since we are talking about miles per hour, so we'll say miles per hour. So let us say that the speed of the current is x miles per hour. Okay, x miles per hour. So let x be the speed of the current. Okay, so a motorboat makes a round trip on a river of 45 miles upstream and 45 miles downstream, maintaining the constant speed of 12 miles per hour. So the motorboat goes downstream. Okay, the speed of that motorboat is 12. Since that is downstream, the speed of the current will be added to that speed of the motorboat. So this becomes here, the speed becomes here 12, which is speed of the motorboat plus the speed of the current, which is x. So the speed going downstream will become 12 plus x. However, here, okay, since this is going upstream and maintaining the constant speed of 12 relative to the water, okay, this becomes 12 minus x. Okay, because you're going against the current. Okay, so what does it tell us is that of course the distance is 45 km and the same 45 km, and the entire round trip takes 8 hours. Oh, we can express our equation in terms of time. Okay, so time upstream and time downstream. Okay, so remember that time is just distance. Let's write that again, that time is just distance over speed. Okay, so time upstream is distance upstream divided by speed upstream. Okay, so what is the time distance upstream? Of course, that's 45. Speed upstream is 12 minus x. Okay. Time downstream is just this speed distance downstream, which is still the same 45, and the speed downstream is 12 plus x. Okay, 12 plus x. And if you're going to add t time upstream plus time downstream, that is just 8 hours. Oh, so that is pretty. So we can say that our equation becomes 45 all over 12 minus x, okay, plus 45 all over 12 plus x. This is time plus another time downstream equals 8. So we already formed our equation, therefore we are ready to solve our. We have here, of course, the LCD is 12 minus x times 12 plus x. Okay, so we're going to multiply this by our LCD. We are left with 45 times 12 plus x. And multiply this by the LCD, we have 45 times 12 minus x. And multiply this by the LCD, we'll have 12 plus x. Okay, so I think we are ready to simplify. We have 45 times 12 is 45 times 12 is 45 times 12 is 540. So this is 540 plus 45x plus another 540 minus 45x equals, this is difference of 2 square. This becomes 144 minus x square. Okay. No, not difference of 2 square, but sum and difference. Okay. Product of sum and difference. So we will have, I think this becomes 0. Okay. So we will have 1080 1080. Is that 1080? Yes, 1080. And this one is 8 times 1 for that is 1152. 1152 minus 8x square. So this becomes 8x square. 8x square equals, that's 8x square equals, how do you do that? 1080 minus 1152, and that is 72. Okay, so 152 minus 80 is 72. Okay, so we can furtherly divide this into that one, and that is 8 x equals 9, and the square root of 9 is 3. Therefore this is our speed of the current. Okay, the speed of the current is 3 kilometers 3 kilometers per 3 miles 3 miles per hour. So let's go back to our illustration that the speed of this current is just 3 miles 3 miles per hour. So meaning if the speed downstream is of the motorboat is 12 plus 3, that becomes 15 miles per hour going downstream, and 12 minus 3 going upstream, that becomes 9 miles per hour going upstream. Okay, covering the same distance of 45 kilometers. Okay, so that's it. So the idea is understanding the concept that the speed of the current is added to the object's speed when going downstream, and the speed of the current is subtracted from the object speed when the object is going upstream. Then you'll go from there. Then we'll have our next. Of course, we have to rewrite your final answer. Okay. So we're going to have our last problem. Our next problem is just the same with the third problem. An airplane makes a trip of 2,400 miles long into the wind, meaning this one is against the wind, and 2,400 miles back with the same tailwind, so mean along with the wind. Okay, maintaining the constant speed of 440 miles per hour relative to the air. So the entire round trip takes 11 hours. Find the speed of the wind. So basically it's just the same with this problem. Okay, but we'll go through with it. Okay, so the speed, let us say that one, that's the speed of the direction of the wind. It's like, oh, like that, like that. That's the wind. There, okay, then there's an airplane. So we don't know the speed of the wind, so this is our x miles per hour, the speed of the wind. So let x be the speed of the wind. So the same idea with the speed of the current. Okay, so distance is the same. Going there is 2,400 miles. Going there is the same 2,400 miles. Okay, but the speed is going here, that's 440. Since there is a speed of this, so let's say this is uh, into the wind. Okay, this is into the wind, and this is along with the wind. So this becomes 440 miles per hour minus x. So this becomes 440 minus x. Since this is along with the wind, it's like the downstream thing. Okay, and this one is like the upstream in our water related problem a while ago. So we have here 44 440 plus the speed of the wind, which is x. Okay, since it says that, oh, it talks about time, therefore we just simply add the two. Okay, so what's the time is distance to 400 divided by this. So that's 400 divided by 440 minus x plus the same round trip, 440 plus x, and that is the whole trip is 11 hours. So pretty much the same. We'll go into details. We'll have LCD as this one. So let's write that here. Our LCD is 440 minus x times 440 plus x. So this becomes 2,400 times, if you're going to multiply this by the LCD, you are left with 440 plus x. Then another 2,400 times 440 minus x. Then we have 11 times 440 minus x, 440 plus x. Okay, so it's a little bit complicated, so let's go and multiply. So multiply this number is 2,400. 24 times, of course there are 3 zeros, that becomes 0. So it's like 24 times 4, 44. 24 times 44 is 1056. So we have 1 million 1,056,000. Then we have plus 2,400x plus another. We have, this one is the same, so we have, okay, 1,056,000. Then we have minus 2,400x equals 11 times, what is 440 square? Because this is just product of sum and difference. So 440 square is 193,600. Then we have minus x square. Okay. This becomes 0. So this becomes 0. So multiply this by 2, you'll get 2,000. Of course, you'll have 0, 0, 0. Then 6 and 6 gives you 12. Carry 1, then you'll get 1. Then 1. Then 2. Am I correct with that? Let's try. I think that's correct. So we have here, you'll have, can we divide this by 11? Because we may not distribute this there, and then just divide. Let's try to divide this by 11. If it's divisible, oh, obviously this is not divisible by 11 because it's 0. So we'll just multiply this, distributed one. So we have 11 times 193,600. So this one becomes 212,600 minus 11x squared. Okay. Then let's subtract. We'll have negative positive 11x squared equals, we have obviously this one is, so it's like 129,600 minus 112. So 129,600 minus 112. Am I correct with that? That is 129,600 and 112. That one. What's this one? This becomes 17,600. Oh, so we have. Okay, maybe we can divide this by 11. We'll get 176 divided 11. 176 divided 11 is 16. So that this is 16,000. Okay. So square root of 16 should not be 16,000, but it should be, yeah, 17,600, 17,000. So x squared equals 1,600. Square root of 1,600 is positive. The positive one is 40. Oh, therefore, that's 40 miles per hour. Therefore, the speed of the wind is 40 miles per hour. Okay. So the speed of this wind, let us say going to that direction, is 40 miles per hour. So therefore, this 440 plus the speed of the wind, that becomes obviously 480, and this becomes 400. The upstream. No, that's up there. Into the wind. Okay. So that's all. That's all 4 problems related to speed, all about quadratic equation.